morning, everyone. Thank you for the opportunity to be here, and thank you all for listening what we have to say. So we're going to talk about Microsoft Fabric and how actually that changed the analyticals game. But before that, let me present myself. I'm Freddie Santos. I'm part of a Microsoft Fabric product group. I'm on the customer advisor team, and let me open for my colleague Lilian to present herself.
Hi, I'm Lilian. I am part from the Industry Solutions Engineering team as software engineer. And yeah, that's it. Go ahead.
So we have like on our agenda for today, we're going to talk about how Microsoft Fabric position in comparison with Azure Analytics Stack. We're going to see some of architectures, and on those architectures, you're going to see from the data lake technology all the way for the data mesh, how we can actually see how it worked and it's still working on an Azure stack, but how Fabric changed the analytical games on those. But the first question that we are looking and we need to answer is, without data, we know that we are just someone with an opinion. But one thing that it's hard over the couple of years is how we can make this data, how we can translate data actually in competitive advantage for our customers. And when we look back and we just saw on the keynote, we have a very fragmented modern tech and analytical stacks. So we can go from everywhere to anywhere using technology. We can go from data integration all the way to the presentation layer with different approaches and different technologies. But as Keen stated on the keynote, the challenge is always the same. How we're going to integrate that, how we're going to provision that. So that complexity is part of our daily jobs, as we know. So if we have that in mind, what we have on Microsoft Analytics portfolio, we have tools that are going to give us the capability to address some of the integration and the problems that we're trying to solve on analytics with data extraction, data integration, data movement tools, databases, governance, transformation tools. So we have pretty much all the products that can attend these workload types. But okay, we do have it, but we also know that it's too far too complex. We know that we have different experience. We need to deal with the platform. We need to deal with file formats, not saying networking configurations. All those challenges are part of our daily jobs as data engineers or even if admins. But when we're looking forward, what do we have on the future? What we are trying to, the problems that we try to solve today with old tools, we have a lot of drawbacks that require a lot of inventivity on our side to overcome some of those challenges. What we have with Fabric is actually a step further. We want to do something that it's easy to use, that is actually end-to-end, from the beginning to the end. We don't need to leave the platform if you don't want. And we have a unified experience from the SaaS experience all the way to have one unified business module, storage, and compute. So here, what we have with Fabric, we have, as we are seeing, a lot of similar names, but we also have different experiences. And as we're going through this presentation, the intent here is to delineate the difference between what we have on our Azure stack and how it works on Fabric. So the first thing that we want to dive deep into is, what is the difference between Microsoft Fabric and Azure Analytics? And here, Azure Analytics, I'm talking about the many products that we saw on a couple of slides ago. And doing that, what I want to do is, let's take off some myths that exist in the Microsoft Fabric. First things first. My son, I have a 5 years old and I have 12 years old. Both boys always ask the same thing when we were watching Superman movies or cartoons. Just the glasses make that much of a difference? The question is, how actually makes sense for Fabric as well? Are we talking about Fabric as a rebrand for Azure Synapse? Because we're talking about an end-to-end experience, right? And when we see end-to-end experience, we might be thinking, okay, Synapse offer me pipelines, offer me Spark engine, offer me MPP engine, but it's not a rebrand. So when we look at Microsoft Fabric, Fabric has different components, different architectures, and it's a SaaS experience. So it's a completely different product and platform as we experience in Synapse. It's not the same thing. It's not also this, guys. It's not also when we're talking about OneLake that is a core part of Microsoft Fabric. It's not just AGLS. We're not just putting a new name. We have new capabilities, new flexibility that we can do with OneLake that is implemented within Fabric. It's not a port. So when we're talking about the Fabric workloads and engines, we are not just getting a dedicated SQL pool that it's a passive infrastructure that have its own architecture and porting and inserting in a SaaS architecture and have the same thing. It's not that. And also, it's not proprietary. Do we optimize files? We do. But when we're talking about the Delta Parquet that Fabric manipulates, it's still an open format. So these things that sometimes we have this wrong impression about Fabric that we are just rebranding the product. That's not the case. We have a new platform with a lot of investment in improvements. Of course, we learn from the products that we had. So Azure Stack offer us a lot of lessons that we understand to try to overcome some of the complexities on the business, the complexity on the technology. We implement in a way that we learn from that, but it's a new thing. It's nothing important. So now that we have that in perspective, let's now dive deep on the actual things, on the technology and what we are doing within Fabric that's different than what I have on Azure Stack. Let's start with Data Lake. So we know Data Lake, and we know that there are advantages and disadvantages that it has. The most important thing is Data Lake came to stay. We cannot deal with data as we dealt that like 12, 14 years ago when we are still manipulating data in relational format. We understand the advantage of scalability and low cost and the flexibility that the data lake offers, but it also brings a lot of challenge. New technologies, new solutions brings new challenge. And when we look at the disadvantages that the data lake has, we're going to see that we have challenge with data quality, because most frequently the data lake become data swamps with other organizations because they don't keep quality on how they are processing that data. Governance over this data is also a challenge that need to be overcome. The silos, complexity, all those aspects are part of a data lake. And as the organizations grow and the diverse data and how we are building up our pipelines, it becomes challenge over and over to manipulate that. Not only that, as we evolve, one thing that we know for sure is data lake tends to create silos and tends to create data movement. And as we know, when we're dealing with our pipelines, it creates data movement and data duplication. And that's a challenge that's very hard to overcome today. So we need to move data from our bronze to gold layers on our medallion architecture. We need sometimes to transform our gold zone from a semi-structure and a structure into a relational type format that you consume data from a relational database or MPP architecture. It requires a lot of data movement and data duplication, and that it's costful because it consumes time for our data engineers. It consumes disk space. It consumes time moving and consisting and clearing this data. So everything here on the data lake, it becomes a challenge to be overcome. And how we can fix that, or how we envisioning the change here with Fabric. So the first thing is OneLake it aims to have one copy. And that is most important because with one copy and have access to specific data sets within our data lake, we can interact using our serverless compute engines, as we saw in the beginning, through the language that we're more used and our teams are able to consume, and then connecting these data sets. But not only that, we can say that data lake is just a store repository that can handle like a vast amount of raw data. And when you see this data duplication and data movement as a key part of our pipelines, more we can say that the integration is where we spend more time than anything. So with one lake, what we can change the game here is we're not forced to duplicate and move data to process it. And we can also manipulate that in a single file for file type format that is Delta Parking. But okay, you told me that, Freddie, but what that means, how we can actually achieve this one copy thing and how you're going to decrease the data movements. And that is through shortcuts. Long story short, we can say that shortcuts are symbolic links, like for those that are from the Unix world, where we actually creating logical or physical links to perform querying or access to the data as they are locally available. So let's assume that we have Amazon S3, where physically my data is stored, and I want to process that data within Fabric. The first thing in the usual word is we need to build up a pipeline that are going to move the entire data lake into Azure Data Lake Gen 2 to process that. With Fabric, that changes. Because with shortcuts, we can create this that shortcut from S3 to one lake, this symbolic link, and we are going to deal with that file as it is local. And through that, we don't need to move entire data sets to process that. We can just work on our data strategy, maybe through shortcuts, do the transformations and storing a gold zone on the one lake. That's possible. We can consume that remotely through the shortcuts as it's local. And that gives us the flexibility to deal with different sources, being even Azure Storage, AWS, and Google. Also, we can actually deal with other types of formats. We are here listing Databricks and Dataverse as well. And that everything we can share in a logical manner, like sharing tables from a lake house to a data warehouse between lake houses without needing to move and create pipelines and ETL to process that. So here, one lake changed the game when we're talking about storage or data lake, because it gives us the flexibility that a regular data lake that exists today doesn't have it. Okay, let's move on for data warehouse. Data warehouse, as we know, is a central database that we use to store curated data in a relational form. So we, in a cloud data warehouse architecture, as we know, we need and we rely a lot on data lake to do their flexibility and the power to deal with all type of data. And we build up ETL or ELT tools to transform that. So long story short, we are very exposed to that architecture. But how that actually works on Fabric? How data lake complement that? We know that the data lake is a source. We can capture and store data that are relevant for our data warehouse. And we can use, talking about a medallion architecture, transformation steps over bronze all the way to silver or gold, then ultimately storing that in relational format that should be consumed by SQL type and perform reports and aggregations and other aspects, as we know. We are here, and when we're talking about Microsoft Fabric, we're going to see now how actually it was before Fabric and how it's today. I'll let Lilian drive this one.
Okay, so let me share my screen. Everybody seeing, hopefully. So basically, what we have in Synapse, it's the dedicated SQL pool, right? I think everybody knows. But just one question: are you seeing my screen, Freddie?
Yes, I can see that.
Okay, just to be sure. Okay, so thank you, Muhammad. So basically, what we have in Synapse, right? We have the dedicated SQL pool. It's super database with 60 distributions. That means that every time that I create a table, that table it's divided in 60 pieces. Those 60 pieces will depend of the pattern that I decide. So if I decide my key is using a hash pattern, the hash pattern is deterministic. That means the same value will go to the same distribution. If it is round robin, that means it to be in a round robin fashion, right? 1, 2, 3, and so on and so forth. So it means that the same key will not go to the same distribution. It can go to anywhere because it's round robin. And you also have the replicate, which will replicate at the level of the node. So you decide the type of your table. That carries a complexity, right? Because if you don't choose well the key that you're going to use to create the tables inside of the dedicated SQL pool, that can lead to what we call it data movement. There are some types of data movement. One is shuffle movement, the other one is broadcast, and there are others. It's quite impossible not have a data movement. Eventually, it will happen, a data movement. And what is a data movement? Data movement means if there is, for example, one situation, if there is an incompatibility of a key distribution, so my fact internet sales is using hash in customer key, and my G customer is using round robin the customer key, or using hash in another column, not customer key. That means the data is not in the same distribution. So when I'm doing the join, the DW needs to sort it out that. So it will redistribute the table. So shuffle is one of those. It will shuffle the data against the distributions. And you can see by this quite simple example here, the point of the query that took longer to execute was the moment that happens the shuffle movement. And that was the total elapsed time, right? The moment that happens the shuffle movement. And that was how much rows I needed to reshuffle. So this is one thing that happens in Synapse, and that's different when we are talking about Fabric, right? Fabric is built on, we have a warehouse and we have lakehouse. This is using Delta format, so you don't have more those complexities to understand how you're going to distribute your table. That's being taken care by the engine for you. You just need to create the table itself. And you have those two options. You have the warehouse and you have the lakehouse. So the lakehouse supports the Python, right? And the warehouse supports the SQL. Another, before I was open this one, but actually I need to go back to this one. Another thing that I need to show you here is the Spark. There is a huge difference in Spark in terms of Synapse. And again, why that changed the game when we talk about Fabric. So first we had the DW outside of Synapse, and then we have Synapse with DW, and with DW we have the pipelines inside of Synapse, we have Spark, and we have serverless. So we have mostly 4 products inside of one workspace. That's Synapse. So we were looking for integration, right? For Spark, the Spark is quite simple implementation here because once you run a session, so once I start a session, that session, it will have a warm-up time, and then it will turn on the cluster, we have a new cluster, and it will take like 3 or 4 minutes to execute. If I want to execute a notebook in parallel, so suppose I have this notebook interactive here, and I want to execute that notebook in parallel, because I want to this example here, I am exporting data from a SQLDB, importing from a SQLDB into the Synapse, right? If I want that to execute in parallel, that would be a little bit, by default, that would be not possible because every time that I execute a notebook and I put that in a pipeline, that's a different session. So that means 3 minutes, startup, 3 minutes, startup, 3 minutes, startup, and so on and so forth. If I want to work around this, I need to use something like thread pool. I also use those references here to look for the thread pool. So the thread pool executor would be something from the concurrent features. It will make me to be able to run the notebooks in parallel. So to trick my notebook and make that run in parallel, I would need to do something like this. What's the difference when we talk about Fabric? So that implementation, it's actually here. So you don't need to use thread pool. If you want, you can. Okay, you are not allowed to use. You still can use the thread pool executor if you want. But there is something inside of Fabric that's called high concurrence. The high concurrence, it's already sharing the sessions for the notebook execution. So as in Synapse, every notebook execution was a different session. As for Fabric, that's not true. You have high concurrency, which will allow us to share the sessions. So that was an improvement. Also, inside of Synapse, if you want to see the data that is inside of the Spark itself, you are going to connect from outside of Synapse, you need to use serverless. So serverless is like the door to open to look the data inside of Spark. You cannot connect, for example, Tableau to Spark. You cannot do that. And that's also different because we have the Lakehouse. You don't need another tool to connect. So you can use the Lakehouse or you can use a warehouse, as I mentioned before. So the implementation is different. It changes the game. It's more integrated and gives you more options. So stop sharing here. Go ahead, Freddie.
Thank you, Lilian. I'm going to share back my slide deck. Yep, as Lilian was demonstrating a visual way is how we organize that. So for the DDW, as she demonstrated, we were talking about on Synapse, we have a stateful architecture. And when we move towards Fabric DW, we have a stateless approach. So if even when we are executing your queries on the dedicated pool, and you guys probably experienced that on the past, if something unexpected happens, your query fails because we have a stateful architecture with a Fabric DW. And now I notice my title is wrong. It's DW on Fabric, not before. We have a stateless approach where we have a complete separation between storage and compute. And ultimately, we can have a stateless approach. Even if a node fails, you can still have your query executing with accessing storage on one lake and performing backend computing pools on that. So that is one aspect from the architecture standpoint. Let's move towards the lake house. So we spoke about data warehouse, we spoke about data warehouse, data lake, but now we came with lake house, and we start lake house by the core of the capabilities that actually enables lake house to exist, that is the Delta Lake. So Delta Lake, long story short, not extending that much, you guys know that pretty well. But just to set the stage, it's a capability to give support towards ACID transactions at the file system or the level, or meaning data lake, creating support for specific actions such as like time travel. We can have scheming force, and we can then perform merge and have also performance improvement. So overall, we have the capability of deal with transactions and have consistent in data integrity at the file levels, in the file system level, on our data lake. And when we move towards with a lake house architecture, in compare with data warehouse, we're not going to state here or use the one's better than another. We do see scenarios and architecture patterns that data warehouse makes more sense than lake house. And the opposite also applies. Depending of the approach, the lakehouse will make more sense of data warehouse. Well, it's important to understand our pipelines and what the problems that we're trying to solve, because through that we can take the decisions based on that. And we are not going to come and say because we are very good with nails, we can solve all problems using hammers. So we have the flexibility within Fabric to adopt that. So we need to make some comparisons with the Lakehouse approach, so we can have more reliability on by keeping the data lake and warehouse consistent. We can do support on machine learning that are not well supported on warehouses. We have unified data management systems. We have flexibility to do data and not be bound by a proprietary format that they're not able to communicate with other tools. But Lakehouse also brings some challenge because one, when we look for a relation database, they are faster, no way around. Even more when we're talking about MPP infrastructures. There is no way we can avoid discussions regarding compute and storage. Of course, when we are talking about compute, it is a very important part. But if we don't work with a strong database engine that performs dynamic data accesses, can build up and create reliable execution plans by considering statistics and other approaches, that cannot be achieved by compute power alone. So that's why relational database is still faster up to date. Also, when we look for security aspects, Lakehouse suffers. Now we are evolving, but we still have some not good support, let me use in that way, for security like RLS, column level security, or even dynamic data masking. It's a challenge because we are not using an engine. So if we still using a database engine, it's still more efficient to perform access methods and build an execution plan than just relying on endpoint. So this type of things, but the most important is when we're talking about relation and database, we are people still use it to that. So it's not a new technology. It's very well sedimented. The people know how to deal with SQL pretty well. Create and build relationships and do joins are easier. So that's one of the challenges when we compare approach with Lakehouse. And as Lydian demonstrated already, we have different on Lakehouse and in Fabric and in Synapse. But overall, we saw already that how our Spark engine within Fabric is more efficient, dynamic, and can actually deliver more with less complexity that we have on Synapse. So let's move for the new thing, the new kid on the block, that is data mesh. When I say that, it's I stole this slide from a friend of mine, but when we are talking about all these platforms, architectures, paradigms, we are pretty much navigating through time from the traditional late 80s with data warehouse, data lake house, and DW over the couple of years architecture, but from 2021 we start to hear about data mesh in as a different architecture paradigm, as we know, and through that paradigm answer new paradigms with old technology sometimes can be challenging. So what it actually means of data mesh, I'm not going to extend myself talking about that. It's beyond, and it's a presentation by itself. But in theory, data mesh is a domain-oriented, decentralized architecture. And we deal with some paradigms as considering data as a product. and it must be decentralized. So means this domain oriented. These domain teams are going to actually to deal and support and manage their own data, creating a self-serve infrastructure, and ultimately having a federated or governance. It means that each domain govern and have autonomy to deal with the data products, meaning they decide how they are going to create, how they're going to process, and how they are going to share the data across different domains within the organization. So what is the challenge for data mesh? First things first, that's not actually a standard. So different organizations implement data mesh in a different ways. It also requires a lot of change in organizational and cultural aspects. It also can create duplication of data when we look at, because as we mentioned, we have data domains, and we're going to see it visually in a couple of slides. And these domains sharing data ultimately create the trends of moving data, duplicating data. And as we know, it costs us time and money. Also, because we are talking about different decentralized teams, it's hard to keep up the same technical level across different teams that are not actually technical experts. So we are going to create some difference between the quality of how we process that data and how we are dealing with those. So, and ultimately, it is start to create silos if these domains are not part of the mesh. So these are some challenges that we see on the data mesh. But in louder I mentioned how it was before Fabric, how it's now. If I don't want to use Fabric and implement a data mesh, pretty much we have different approaches that we can have with Azure Synapse. By adopting different Synapse workspaces, sharing a same data lake. By doing that, we are actually using the same storage account across different workspaces, and then we start to have a centralized aspect. Oh, okay. I was hearing something. Okay, we can also have different one single workspace or different workspaces in different regions, and within that we can create different domains. But also we need to have aspects such as security, network to integrate those. And we have also other aspects by implementing connectivity, Azure policies, fire rules, and all that stuff that are part of our the data mesh architecture. I put on a link, and then after we're going to share the slide deck. This link, it's how we can create data mesh with Azure Synapse. That was written by a friend of mine, Amanjit. I strongly recommend you guys take a look on that if you are planning to use data mesh on Azure Synapse. But how that actually works on Fabric, how it changed the game. So overall, it's one lake give us the true data mesh as a service. Why? Because we can create different workspace for different organizations or data domains within our Fabric tenant that are going to have a serverless approach by using different workloads and engines to process the data as they need. So one lake, we can create our structures and share the data with one copy, because now we have the shortcuts capability where we can share data between those domains and unifying the governance and have the management between different domains over our same tenant. So we can consume that. And we can share this data through our shortcuts, as I mentioned, to have the mesh capabilities without needing to move data. So we overcome some of the limitations that we know that come with the data mesh by creating shortcuts and sharing the data as we need for different organizations and domains within our Fabric tenant without needing to move and duplicate the data. Just that, it changed the game and make your decision to move in a data mesh architecture easier, because we offer the technology. It's a new technology that contemplates that from scratch, a data mesh approach that can be definitely supported in an easy way without you need to expend time and hours planning and design security systems, firewalls, networking. Everything just works within your Fabric tenant. And move that, we are going to our last demo for Lilian in an end-to-end approach with Fabric.
Oh, hi. Sorry, I'm just trying to share right screen. Okay. Hi, are you seeing my screen? Hopefully, yes. So for this one, I will. So you're talking about Fabric, right? And how it changed the game. What was improved in the whole concept of Fabric? Fabric is a software as a service, right? Different Synapse are platforms as a service to comparing our own product. So the goal is a little bit different. It's more integrated. Because it's more integrated, we can do different things, right? So when you look at the Fabric, you have different options. So you are integrating with real time, you are integrating with data warehouse, you are integrating with data factory, and you also have data activator. So when we were talking about this demo, we thought, let's try to make a demo that we can do everything inside of Fabric. So for this one, we decided to go with this option, the real-time analytics option that we have inside of Fabric. So for the real-time analytics, I think Shu Sharma is, for me, the best reference of a great example for a demo. So Anshu created this example, which basically will look the International Space Station where it is, the localization. It will monitor, send that information through logical apps to event stream, from event stream to a TQL, and then he creates some dashboards. I understood his idea, and I want to do almost like he did, but a little bit different. I want to do everything inside of Fabric without the logical apps. So for this, I decided to go with the notebooks. So what I'm trying to achieve here is monitor the API, check the localization, and from the localization, Jason. And from the localization, get the response and see where it is. So see, I see that's the API. I see that's the position that is, and it is changing, right? That's what we expect. So for this, basically I try to test. So here I'm using requests. So if I get the request, I want to see the response. I got the response, great. So 200 works, and that's the position. So to connect, in order to connect in the event stream, I choose this library here, Event Hub. So I'm using this library to connect to event stream and to create a scheduler to start to start to send the stream and then stop when I want. I'm using this other library. So I'm just copying and also paste here in case someone wants to take a look on the libraries. Here it goes. Okay, and back here, back where I was. So I left here running for some time because I want to accumulate some data. So see, it's running for 15 minutes now. So basically, this is a function. I am checking the response of the library. I'm being sure this data has a JSON format that's quite relevant. I got the connection string. From the connection string, I'm using the producer wishes from the Event Hub library to create a batch and send that information. I use the APS scheduler to start sending the information. So start a job that will send that information every 5 seconds, and that's it. And then I'm connecting to the event stream, right? So this is my notebook, and I'm connecting to the event stream. Basically, just for you to understand how that's done, basically what that would be is the option that I chose was custom. And to connect, I just went here to connection string. So I went here to connection string, that's the whole thing that I need. And then I added here to the event hub. So once I did this connection from one to the other, I have the data sent from Spark to the event stream. If the data is sent to event stream, I most likely would be able to see it here. And I have the data. Now sending to the custo. That's super simple as well. So you need to create a custo database and then define the destination, the workspace. My workspace is this one, the database. And then the next step is configure. I will quickly show the configuration, then we go to the KQL because I know we are short in time. I'm trying to do everything when it's set. Another when it's still running, right? So to be a little bit slow. Another thing, because this is an event stream, that this is real-time analytics, you see here, right? You can connect multiple sources and then event stream to multiple destinations. Of course, if you have multiple sources and you are sent to, for example, the same destination, you have a point of a data format, right? You just need to be careful that you are sending the same data format. Okay. 1, 2, 3. So here we go. So why I say the JSON is important? Because here you're going to define the JSON format. That's why in the notebook, I was being sure that I have the JSON format. Another thing that's important here is if you look my JSON file, this is 2 levels, right? One level, second level. So when I'm configuring this here, I need to tell I am using nested level. So then I have one column for longitude, one form for latitude, message and timestamp. I have everything that I need. Let me, yes, cancel, delete this because I already did this configuration. I just want to show you how it's done. Okay, so once the data is sent to the TKL database, the next thing that I have, which is great, I have the International Space Station monitoring. So I can see it's moving through the space where it is, and I can even go further because I'm seeing the where it is. I can also, for example, create an alert. So I could use something like a data activator. I didn't let it open. A data activator to create an alert every time the International Space Station is maybe close to some country close to a specific place. And basically, the data activator, if you decide to configure, you're going to configure on the event stream. So you're going to say here in the event stream that the data that you are streaming, you are sending to Reflex. From the Reflex, you're going to create a custom one, and you're going to say, okay, create a new trigger every time that the International Space Station enters in a certain range. And what you're going to have like something like this. For example, I did this test last year, as you see here. And basically, every time the ESS enters in a certain range, in a certain position, I configure to receive a message in Teams saying that to me. So, and that works pretty fine. One thing that is for that works, everything must be in the same tenant. So the tenant that's Fabric and the tenant that your user is, the teams, everything must be in the same tenant to work. So you cannot do this cross tenant. Okay, so that's it. This is an example end to end that I create the event stream from the notebook to the event stream, from the event stream to the custo database and using Reflex to get that information, the trigger the information to me. And yeah, that's all. Freddie?
Thank you, Lilian. Let's just move on for our end of our presentation. We had what we saw here is how Fabric empowers and help us from business analysts, data engineering, science to achieve more in a well-integrated and easy maintenance SaaS platform. And we could now send the difference between internal components and engines that we have within Fabric and Synapse and Azure Stack and say, hey, this is the difference, how we can actually approach with Fabric different than Azure. As Kim stated on a keynote, we have, if you want to learn more about Fabric, we're going to have the community conference on Vegas. I hope to see you guys there. And if you are interested on knowing more about Fabric and expand your knowledge on the different engines and how we are implementing things within Fabric, I invite you guys to join us on March between 26 and 28. And with that, we go to the end. Thank you very much for listening us and an opportunity to hear what we have to share about Fabric. I really appreciate your time, guys.